Richard Dawkins, described as a genius by some, a giant slayer of religion by others, and a godless, misguided, to be pitied creature by religious opponents. Well, whatever you think, without doubt, he's one of the most quoted scientific figures of the last few decades and one of its most controversial figures. And in his brilliant new book, I loved it, I couldn't put it down, The Greatest Show on Earth, The Evidence for Evolution, that's published by Bentham. It's copiously illustrated with dramatic photographs, maps, diagrams and illustrations. He states, that's a bit of a long intro, Richard, but I just wanted to quote you from the intro there. You say, evolution is a fact, beyond reasonable doubt, beyond serious doubt, beyond sane, informed, intelligent doubt, beyond doubt. Evolution is a fact. It is the plain truth that we are cousins of chimpanzees, somewhat more distant cousins of monkeys, more distant cousins still of aardvarks and manatees, yet more distant cousins of bananas and turnips. That didn't have to be true. It's not self-evidently, tautologically, obviously true. And there was a time when most people, even educated people, thought it wasn't. It didn't have to be true, but it is. We know this because a rising flood of evidence demonstrates it. No reputable scientist disputes it, and no unbiased reader will close the book doubting it. Well, welcome to you and congratulations on yet another very thought-provoking and accessible read.
Thank you. That sounded very convincing when you read it out.
Well, yeah, I mean, I'm totally convinced. You've got me utterly and totally. Mind you, I've been convinced for a long time, but you just convinced me even further.
Yes.
But I thought what we'd do, just to start off, because there are still lots of people listening who don't perhaps understand Darwin's theory of natural selection. And I thought I'd ask you to explain that in layperson's terms, which you always do so brilliantly, because you make science so accessible.
Well, the great mystery, of course, was to explain how it is that we have this enormous variety of living things and looking so beautifully, quote, designed. They look as though they've been designed for a purpose. And this was always a great riddle, and it was always solved in people's minds by saying it was done by a creator. What Darwin did was to come up with a much better explanation, which is that every species on Earth is descended by gradual evolution from other species, ultimately from a single ancestor. So there's a great tree of life, starting with something like bacteria, and then branching and branching and branching and producing all the plants, all the animals, the birds, the mammals, the reptiles, the fish. Everything is a cousin of everything else. Now, natural selection is the idea that Darwin put forward to explain why living things look so well designed. Because evolution is not just change, it's change in the direction of improvement. And the way it works according to natural selection is that in every generation, some individuals survive better than other individuals. Some individuals are better at reproducing. Perhaps they're sexier and get mates more easily. Perhaps they are better at running away from lions. Perhaps they're better at catching antelopes. Whatever it is, some individuals survive better than others. They are the ones that reproduce, and they are the ones that pass on the genes that help them to survive. And so as countless generations go by, animals and plants get better at surviving. And that's what it's all about.
And which begs my next question, which is, and you have a super chapter on this with lovely, wonderful photographs. We breed superior horses, we breed dogs, we breed cattle by human intervention. What's the force in nature that selects?
Right. Well, every farmer knows, every gardener knows that you can breed things to get better. You breed cattle that are better at giving milk, you breed horses that are better at running, you breed pigs that give better meat, and so on. Everybody knows how that works. Generation by generation, you choose the individuals who have the characteristics that you want, and you breed from them. And as the generations go by, they get better. Darwin's great insight was to see that you don't actually need to have a breeder. You don't have to have a human choosing which ones to breed. Nature does the choosing for you. Nature does the choosing by certain individuals surviving better than others, so automatically they are the ones that breed. They are the ones that pass on the genes that made them good at surviving in the first place. And good at surviving is, of course, different in every species. In the case of birds and bats, it means good at flying. In the case of fish and whales, it means good at swimming. In the case of lions and antelopes, it means good at running, and so on.
So our evolutionary stages are transmitted from one generation to another by genes. It's all about genes.
It's all about genes. It all takes an immensely long time. One of the things that people don't realize, I think, one of the reasons why people find it hard to understand, is that it does take an enormous amount of time, far longer than anybody can actually imagine.
And then the importance of DNA. I mean, Darwin had no notion about DNA. We can put it more precisely. I think you put it like this in the book. You say it's the non-random survival of information that encodes embryological recipes for their own survival. And they're the ones that tend to survive. So DNA is very special because it's not because it survives in its material self, but because it survives in the form of lots and lots of copies. Am I right?
Absolutely right. That's a very, very important point. In Darwin's time, of course, DNA wasn't known. Even genes weren't known. Darwin just knew that there was something that passed from generation to generation. Heredity was a known fact. It wasn't an understood fact. Then genes were sort of vaguely understood, and then in the 1950s and 60s and so on, it became clear that it was DNA that did it. So, Sorry.
No, go on, sorry. Go on.
DNA is a digitally coded set of instructions for building a body that's good at surviving. And those DNA codes that work best, which means that are best at programming bodies that are good at surviving, those are the DNA codes that survive. What is special about DNA is that it's digital. It's like computer tape. Modern genetics has become a kind of branch of computer science. And it's because it's digital that it's very, very free from errors. It's almost perfectly accurate in its copying, which it has to be in order for evolution to work. But it's not quite totally accurate. If it were absolutely totally accurate, then there would never be any variation for natural selection to choose between. There are occasional mistakes in the copying of DNA. They're called mutations. And mutations feed in variation to populations. And in that variation in a population, those individuals that survive best, for whatever reason, different in different species, pass on the DNA.
So we need those variations.
We need the variations, but they're extremely rare, and it's just as well they're extremely rare. If they were common, the whole system wouldn't work.
Now, here in South Africa with our Cradle of Humankind at Marapeng, and we hope you're going to come and visit at some stage. We've had a lot of great exhibitions this year, or last year rather, because of the bicentenary and the publication of the origin of the species. And we know, well, I think I'm right in saying we know that it seems to be Darwin's experiences in Tierra del Fuego, particularly, which seemed to be his most important voyage, when he returned those so-called civilized Fuegans who'd been in England and met the King and Queen, and saw when they came back to Tierra del Fuego how quickly they reverted to type. And this seems to have led him to question man's place in God creation, because humans can now be seen as mutable. And it seems then that Darwin begins to ask the question, where do we come from, which of course upended religious dogma that said we were all divinely created. Now we know that humans have evolved just like any other species. Can you just talk us through that too? Yes.
Darwin was rather hesitant about talking about humans in The Origin of Species. He left that to a later book called Descent of Man. Darwin had a strong intuition that the evolution of humanity took place in Africa. It was not a fashionable view for a while, but Darwin has been completely vindicated. All the fossil evidence now shows that the evolution of humans for at least the last 9 or 10 million years has been entirely in Africa. And some of the best fossils have come from South Africa, some of the most striking fossils. The common ancestor with chimpanzees, which is, well, man is an African ape like chimpanzees, bonobos, and gorillas. So the branching off from orangutans and gibbons took place earlier, and they're the Asian apes. Once the African apes started evolving, they branched into gorillas on the one hand, and then chimpanzees and humans on the other, and then chimpanzees and humans branched into humans and chimpanzees. Chimpanzees branched into common chimpanzees and bonobos. We have a fairly good fossil record now of the human line since the branch point with chimpanzees, which was about 6 million years ago, entirely in Africa. Obviously, most of the good fossils are relatively more recent, from about 3 million years on, and these are in both East Africa and South Africa. The ones about 3 million years ago, they're all of the genus Australopithecus, which means southern ape, first named in South Africa. There are various species of Australopithecus. One of those species of Australopithecus must have slowly changed into the first species of Homo, possibly Homo habilis, which then changed into Homo erectus, which then changed into Homo sapiens, which is our species. There were quite a lot of species of humans in Africa, and all of them have died out except one, Homo sapiens.
And, talking about the fossil records, I mean, you touch upon a very sort of touchy point, because creationists are very enamoured of the fossil record. And you say because they've been taught by each other to repeat over and over the mantra that it is full of gaps. Show me your intermediates. You still haven't found the missing link, they cry. Your response to that?
Well, it's just total nonsense. And there are numerous missing links. In Darwin's time, there were no human fossils at all. We had living chimpanzees, we had living humans, and we had nothing that connected them at all. Of course, there are no fossils connecting humans and chimps in the sense that we're not descended from chimps. Humans and chimps are descended from a common ancestor, which we now know lived about 6 million years ago. And I've mentioned some of the fossils, like Homo erectus, Homo habilis, Australopithecus africanus, mainly from South Africa, Australopithecus afarensis, mainly from East Africa, Ardipithecus, Sahelanthropus, and Sahelanthropus, I should have said, and various others from different parts of Africa. All of those could be described as missing links, but they're not missing any longer because we found them.
And as I say, we're in a very privileged position here because we have wonderful fossil displays very often at Maripeng here, where the public can go and see them and be talked through them too. You talked about out of Africa, the great exodus of our ancestors from Africa, but there wasn't one, there were two. I don't know what the plural is. Is it exodi or exoduses or
no,
whatever?
I think two exoduses will do fine.
Okay, but there were two, weren't there?
Yes, there were. Homo erectus exodused from Africa maybe a 1.5 million years ago, maybe 2 million years ago. And that was a much earlier exodus, and that gave rise to famous fossils such as Peking man and Java man, which are not Homo sapiens. They've got a quite different kind of skull. They're quite different from modern humans. So Homo erectus were in Asia 1 million years ago, 1.5 million years ago. And then much more recently, maybe only 100,000 or a couple of 100,000 years ago, Homo sapiens went out of Africa. There was a second exodus from Africa of Homo sapiens. And that was the exodus that gave rise to all the non-African peoples.
I've got an SMS here, and there's a couple of callers want to talk to you. Is global warming part of evolution?
No, it's not. No, it isn't. It is something. It's a possible catastrophe that's going to overtake us. There have been many such catastrophes before, and they influence the future of evolution, but they're not a part of evolution, no.
Because you know, I know that Darwin was one of the first to point out the interconnectedness of all life. I mean, he said, I think he described it, the image he used of a great web, and if we destroy that, we destroy ourselves. But as you've just said, extinctions are in fact a regular facet of nature. I think what the caller is perhaps suggesting, are we in the middle of the so-called sixth extinction, the great man-made extinction?
Are. Yes, I mean, extinctions are a regular feature. That's not to say that we should welcome them or anything like that.
No.
I mean, they are catastrophes, and the previous 5 extinctions have been horrific catastrophes. So, I mean, what usually happens after a mass extinction, a really major mass extinction, like the one that killed the dinosaurs 65 million years ago, what usually happens is that after a brief pause, there's a new flowering of evolution. When the dinosaurs went extinct, all the gaps that were left were filled by mammals, and it took maybe 5 million years for the mammals to fill all those gaps. So if we really do cause mass extinction, that might open the floodgates to a new round of evolution, and that would be interesting, except we shan't be around to see it. But it's not an actual part of the evolutionary process, no.
Rob says here, thanks so much for the book, he says, as it's helped my role as a biology teacher. He wants to know what your views are on epigenetics, and would you recommend Bad Science, the book? We've actually talked to, I think it's Ben
Goldacre.
Ben Goldacre. He was fantastic.
Yes, I recommend Ben Goldacre's book, Bad Science. He discusses various examples of scientific nonsense, medical or pseudo-medical.
Yes. Yeah. Oh, he was great. Medical. He was absolutely great.
Yeah, he's very good. Did he actually go out to South Africa and visit?
No, we did it by phone, alas. We're trying to get all you people to come and visit properly.
Yes.
You know.
Well, I have visited from time to time.
I was given bad information. I was told you hadn't recently. Well,
not that recently, but maybe about 5 years ago.
Well, that's fairly recent. Now, I don't even know what epigenetics is or are.
Well, it's a fashionable word that's going around at the moment. I don't think it's that interesting to talk about on the air, actually. It's rather an esoteric subject.
Okay.
It's sort of... It's the idea that there are, or is usually used nowadays as the idea that there may be something a little bit, something that can get into the genes from the environment in a way that would not normally have been expected. It is a fashionable idea. I don't think it's actually a very great evolutionary importance. Okay. I'd rather not spend any time on it.
Okay, there you go. Question. There you go, Rob. So forget it. Ian, hi, Ian. We've got Ian on the line. Yeah.
Hello, Kate, and hello, Professor Dawkins. Yes, I've read The Blind Watchmaker, and I'm reading The Greatest Show on Earth, and I really enjoy his books. I think they're very scholarly and very stimulating. Now, by his argument of evolution, what I can't understand is his vehemence against religion. I mean, it reaches, one thinks, fever pitch at times. I mean, obviously he's written a book on it. And I would take issue over something he said to Alan Bolton in my interview. Bolton put to him that a lot of the ethics we take as secular now actually came from religion, and Professor Dawkins was biblical.
Ian, this is really a shocking line. I'm really sorry. I can't hear what you're saying, and I don't know.
I got a little bit of that. Let me try and answer what I did hear, which wasn't all of it.
Okay.
It was that he agreed with what I was saying about evolution, but he thought I was too vehement about religion.
Yes.
I don't think you'll find any vehemence about religion in either of the 2 books you mentioned, The Blind Watchmaker or The Greatest Show on Earth. The one book I've written, which is an anti-religious book, is The God Delusion, which was my previous book. I don't think even that is actually very vehement, although a lot of people have said it was. I think that people sometimes hear vehemence when there isn't any, and the reason for that is rather interesting. It's that we've been brought up to believe that you can't criticize religion. You're not allowed to criticize religion. And therefore, when somebody offers even a rather mild and gentle criticism of religion, it sounds vehement, even if it isn't. I think it may be as simple as that.
Somebody said another message. How can I want to condense this because I'm sight reading these as they come up. God can't coexist with a belief in evolution. Are you postulating that they're mutually exclusive?
They can't be literally mutually exclusive because there are plenty of people, plenty of scientists are religious, and plenty of clergymen believe in evolution. So that at least shows that some people can hold the two beliefs in their minds at the same time. I find it rather difficult. I find that a full understanding of evolution does undermine religious belief, but that may just be me. It certainly seems to be quite a lot of other people as well, and I put the case for this mostly in my other book, The God Delusion, rather than in this one, The Greatest Show on Earth.
The evolution is not inconsistent with the Bible, Genesis. Let the earth bring forth, says Lee Impal.
Well, you can say that sort of thing. I mean, if you really, really want to bend over backwards to find verses of the Bible that are compatible with modern science, you can. But the general thrust of the Bible is not, if you take it literally, compatible with modern science. And there are many churchmen who reconcile it by saying that the Bible is merely symbolic. I mean, it's very hard to, you may reconcile it with that thing about let the earth bring forth, but that's pretty vague, really, isn't it? I mean, it doesn't really tell you very much. Whereas beginning of Genesis is remarkably specific. It tells you the exact order in which God did things, and they are totally incompatible with what we know of science.
Lucas, hi Lucas.
Hi, Kate. How are you?
Great, thank you.
I'm good. My question is very simple. I would like to ask the professor there whether evolution works out religion.
How do you mean, Lucas?
I mean to say, because we are, like he mentioned earlier on, that we grew up being told that we can't criticize religion. Mm-hmm. Yeah, I find that a very strong statement, because now the Holy Scriptures, they tell us that the people who have been created by God. Mm. So now evolution, it tells us that we evolved from animals or other life forms. So I would like him to clarify that one for me.
Okay,
yes,
thanks,
I will gladly do so.
Okay.
I think the only way you can reconcile them is to say that what the Bible says is symbolic. If you take the Bible literally, then it is wrong. It is quite simply wrong. But what most modern churchmen are doing is saying, we don't take it literally anymore. We believe that it is some kind of an allegory, some kind of a myth, which is not to say that it's bad, but you cannot take it as literally true. The book of Genesis, where it describes how God created the world and living things, if you take it literally, that is just plain wrong, and science has shown that beyond reasonable doubt.
Please stay on the line. We're taking a break. We've got lots and lots of calls about extraterrestrials and all sorts of things. What about the Big Bang Theory? Intelligent life elsewhere? Have we stopped evolving? Loads and loads of questions coming in for you, Prof. Dawkins.
On 92.7 and 106 FM, Talk Radio 702, your number one news and talk station. Call Believe It or Not on 011 883 0702.
I'm talking to Professor Richard Dawkins about his latest book, The Greatest Show on Earth, The Evidence for Evolution. It's available in all our bookshops now, published by Bentham. Well, I really don't know where to start with all the questions, but maybe just to say Liz says that you are her hero as a biology teacher. You are her ultimate teacher. Sharon in Rondebosch says, thank you for being such a remarkable, rational, reasonable and readable thinker. You make science totally accessible and riveting stuff. So I'll give you that. And other people saying, if only you would come here and deliver lectures, please. Mel, you've got an interesting question here. Hi there. Hi, Mel.
And your guest. I heard a biologist, Steve Jones, suggest that human beings have stopped evolving. I'd just like Professor Dawkins' opinion on that.
Okay, good one. Have we stopped evolving, Richard?
Well, there's every reason to suspect that we might have done, because natural selection, as I said earlier, depends upon some individuals surviving and others not. And the problem with modern humans is that it's pretty easy to survive, because we tend to be looked after by the society. We have hospitals, we have vaccinations, we have clean water, all sorts of reasons why under the conditions when our wild ancestors would have died, we don't. And so the reason why some people reproduce and some people don't reproduce is no longer that some survive and others don't survive. Most people survive, and the question then is, given that you survive, do you reproduce or not? Because, of course, what really matters in evolution is whether you reproduce. Mm. Well, not everybody reproduces as much as everybody else. Some people have lots more children than others. And if there were any genetic component to which individuals have lots of children and which have none, then that would be natural selection. Well, I don't know whether there is a genetic component, but I think it's unlikely that if there is, it would be sustained for a sufficiently large number of generations to give rise to an evolutionary change. You would need to say that whatever it is that makes some individuals have lots of children, whatever genes it is that make them have lots of children, and it's got to be genes or it's not evolutionarily important, whatever it is lasts for, hundreds of thousands of, not perhaps about tens of thousands of years in order to be evolutionarily significant. And that might not be true. So it's possible that Steve Jones is right, that we stopped evolving. But other people point out that there are differences in patterns of disease. So there are genes that favor survival more than others, so it may not be as simple as that.
Which really, Gail, who's the student, has sent an SMS saying, what are your thoughts on evolutionary medicine? How far are we from using its applications in clinical practice, she says. I don't even know what evolutionary medicine is, I don't think.
Well, there's a book on the subject by Randolph Nesse, that's Nesse, and George C. Williams, a very, very good book. Mm-hmm. It's really just trying to persuade doctors to take a Darwinian view, to ask yourself, asking doctors to ask themselves what actually makes us ill. Why do we sometimes get ill? From a Darwinian point of view, I mean, one possible answer is the reason why we have back pain and similar things is that our evolutionary heritage has left us with kind of crocs. It's not that long ago we were walking on all fours. And when we rose up onto our hind legs, our skeletons were not ideally built for walking on two legs, and so we get back pain. There are many other examples of disabilities which flow from the fact that we have a recent history in a different environment. Another sort of way of applying Darwinian ideas to medicine is to point out that bacteria and viruses and other sorts of parasites are themselves evolving. So when you, say, have a cold and you're sneezing a lot and you have a runny nose, you could ask yourself the question, is your runny nose and your sneeze and your cough, is that something that's directly produced by the parasite, the virus or the bacterium, whichever it is, or is it a response by the body, by your own body, to attempt to get rid of it? If it's an adaptation by the virus, in the case of a cold, is your sneezing and is your runny nose an actual adaptation to get itself passed on to another individual? If you take something like malaria, where it's extremely debilitating to the human, it makes the human who gets malaria lie down in a fever and be unable to do normal work.
And often die.
It's carried by a mosquito. The malarial parasite doesn't make the mosquito feel at all ill. And that, of course, is good for the malarial parasite, because the human is very sick and so can't fend off the mosquito. The mosquito comes, bites the human, picks up the parasite from the human's bloodstream, and then the mosquito isn't made to feel ill at all. The mosquito happily flies off and injects the parasite into somebody else. So you can see the whole thing as orchestrated for the good of the malarial parasite. The malarial parasite both makes the human prostrate, lie down and be unable to move, so it's an easy target for the mosquito. But it doesn't make the mosquito prostrate at all. The mosquito is free to fly about and inject the parasite into others.
Doesn't seem fair, does it?
Sorry?
Doesn't seem very fair, does it?
Oh, well, it's very fair from the evolutionary point of view. It's exactly what the malarial parasite needs. In the case of cholera, it's spread in water, and once again, you can make a convincing case that it's perfectly adapted to spread itself through water. Something like the common cold spreads itself not through insects or through water, but by direct contact. And there, of course, what the parasite wants, in quotes, what the parasite wants is for the person to be not ill enough to have to go to bed. When you have a cold, you on the whole don't go to bed, you go into work, and you infect somebody else, which is just what the parasite wants. In the case of a rabid dog, or a rabid a hyena or something, it makes the dog foam at the mouth, which carries the parasite. It makes the dog bite, which injects the parasite into the wound, because the saliva is injected into the wound. So everything about the behavior of the rabid dog is perfectly adapted to spread the parasite. So you can see the symptoms of rabies, or the symptoms of cholera, or the symptoms of malaria, whatever they are, as being well adapted for the parasite to get itself passed on. And there are numerous examples like that.
Clint's got a good question. Hi, Clint. And in fact, in the book, Clint, Richards has a whole chapter on clocks and measuring evolution. Your question.
My question to you, Professor, is what's the most accurate form of telling the age of the Earth? As it's throughout the time,
right.
Scientists have always changed their minds and come up with a different amount of time, millions, and then it was billions, and now it's sitting at 4.5 billion. It seems like a long time ago.
As time goes by, the methods get better, and it's pretty much converged on about 4.6 billion now. It's mostly done by radioactive decay. Different radioactive elements have different half-lives, and the half-lives range from tens of billions of years at the long end to fractions of a second at the short end. And so by looking at the quantity of the radioactive element that's still left in a rock and the product of the radioactive decay that is in the rock, by comparing those two, you can calculate, knowing what physicists tell you about the half-life of the isotope, you can calculate how old the rock is. Now, fossils don't. This only works in igneous rock. That's things like lava, because that's when lava solidifies, that could be thought of as zeroing the clock. And fossils don't form in that kind of rock. They form in sedimentary rock. You can't date sedimentary rock directly, so you have to date the igneous rock, the lava-type rock, that's associated with the sedimentary rock. But now that's been done a great deal all over the world, and so we now have an extremely good and full picture of the age of each sediment of rock and the fossils that are in the sediment of rock. And the same method gives us the age of the oldest rocks on Earth. And we can calculate that the age of the Earth, indeed of the whole solar system, is about 4.6 billion years.
Before I come back to lots and lots of questions coming in, you have a fascinating section on Lenski and the E. coli bacterium, which proves evolution. Again, in layperson's terms, can you talk us through that?
Well, of course, humans don't live long enough to see evolution happen, because we only live a few decades, and evolution takes millions of years. But there are some creatures, such as bacteria, that have generation time that's measured in, minutes. And so the amount of evolution that can take place in bacteria is hugely greater. And Richard Lenski in America, Michigan State University, exploited this by setting up lines of evolution in bacteria, in E. coli, which is a very common bacterium from guts. he set up 12 lines of evolution in the lab in flasks. I think of them as the 12 tribes. And these 12 tribes, each one was a line of flasks. Put bacteria in the first flask, leave it there for a day, leave them to multiply for a day, and they multiply hugely. Then take a tiny sample from flask 1 and drop it into flask 2. And then next day, take a tiny sample out of flask 2, drop it into flask 3. And that goes on for thousands and thousands and thousands of days, thousands of flasks, going on and on and on for decades, allowing the bacteria to evolve through these lines of flasks. Now, he did it 12 times. That's to say there were 12 independent lines of evolution, and I call them the 12 tribes. Mm-hmm. And they did indeed evolve. They evolved to get better at surviving in the chemical environment that was being provided by Lenski in these flasks. They got better at exploiting the food supply. They changed in all sorts of ways. And the 12 different tribes all changed in different ways, but they were sort of parallel. They were similar ways. They were all improving in their different ways, which is a very good model for what happens in real nature. Now, a fascinating aspect of this is that bacteria can be frozen. So at any time, Lenski could take a sample of the bacteria from any one of his flasks and put it in a deep freeze. And that was equivalent to a fossil. So at any time, he could go back to the fossil of, say, generation 23. If he wanted to see what generation 23 was like, he could unfreeze it and then take generation 23 unfrozen and see how it performs against the competition of, say, generation 136, which is a fascinating luxury, to be able to bring your fossils to life and see how they survive against more recently evolved creatures. That could only be done with bacteria.
Several questions encapsulated in this one. What about the evolution of consciousness and mind?
That's a very, very difficult question. It's a philosophical question as much as anything, not necessarily a question for a biologist. I am a biologist, and the best I can do is to say, obviously, consciousness and mind have something to do with brains. They are a manifestation of the activity of brains. Exactly why the activity of brains produces the subjective feeling of consciousness, the feeling of what it looks like to see something red or green, what it looks like to hear a trumpet or an oboe or a drum, what it looks like to smell onions or roses, that is a very profoundly difficult philosophical question, and I'm not sure that biologists are the best people to answer it. What I am confident of is that it is a product of the evolution of brains. It's not something disembodied. It's not something that sort of hovers about separate from the material brain.
Please stay with us. We're going to take another break and then coming back to lots and lots of questions and queries.
Have your say. SMS Believe It or Not with Kate Turkington now. 31702. Talk Radio 702.
Rainer says, although I think you may have touched upon it earlier, if the environment changes radically, for example, global warming, won't we actually evolve to fit in with those surroundings, fit into the circumstances?
That's a very good point, and yes. we hope that we would. I should think that wild animals probably would, and we might as well. It's happened, of course, many times before when the environment changes, so it's a good point. Nevertheless, a lot of creatures probably will go extinct if the environment changes too rapidly. That usually does happen. Extinction is not a part of evolution. Extinction just happens, and it's very sad when it happens.
Here's a very thought-provoking question. Is it not possible, says Peter, that the whole evolutionary process could now be going backwards? In other words, the proliferation of lesser intelligent humans as opposed to the dying out of the more advanced of the species?
Evolution never actually goes literally backwards, because there are so many ways of moving that it wouldn't actually follow the same exact pathway backwards. You picked out a particular example which is less intelligent. Intelligence is only one way of surviving. There are lots of other ways of surviving, and intelligence happens to be the way humans survive, but lots of other species survive in other ways. And there doesn't seem to be any obvious reason why the most intelligent individuals in modern humans survive and reproduce better than others. There must have been a time during our evolution in Africa during the last 3 or 4 million years when intelligence was favored by natural selection, because brains have got bigger. The brain very dramatically got bigger from about 3 million years ago onwards. And that must have meant that in successive generations, the brainiest individuals in some sense were the ones who survived best or reproduced best. It isn't obvious that's going on anymore. And your questioner, your caller, may well be right that the less intelligent individuals are now the most likely to reproduce, in which case evolution, that particular thing, that particular aspect, namely intelligence, could start going backwards.
Audrey says, according to evolutionary theory, is there any point to our existence?
Well, we each make our own point to our existence, don't we? And each of us has a different answer to the question, what makes your life worth living? Everybody has a different answer. And many people's lives are indeed very, very worth living. I like to think that mine is, and I think probably Audrey's is as well. But there's probably no global, general point to existence. It's probably not right to say that the whole of life has one exalted point. If there is one point to life, it is simply propagation of DNA, which is not a very exalted, not a very high-minded point. So I think the answer is that each of us should make our own points.
Evo Devo, says Louis, who's a zoology student. What are your thoughts on Evo Devo? Presumably evolutionary devotion. I don't know the term.
Development.
Development. Evo Devo.
Yeah. Development meaning embryological development.
Okay.
Embryology is the process by which a fertilized egg gives rise to a baby, well, ultimately gives rise to an adult. It's always been clear that a full picture of evolution has to take account of development. In every generation, it's the genes that are selected, but then the body that's produced is the end result of a process of development. And so the full picture has got to include development, and modern studies of evolution and development are indeed exciting. It's one of the most active fields of research in biology at the moment, yes. Hang on, you write that. I've got so many notes here I've been making. You say that nature is neutral. It's neither kind nor unkind. She's neither against suffering or for it. Nature is not interested in suffering one way or the other unless it affects the survival of the DNA. That's absolutely right. I mean, suffering is something that humans are intensely preoccupied with. Obviously, not just our own, but other people's, even other species suffering. Nature is completely indifferent to suffering. And so natural selection will favor the leopard or the lion that is the most efficient killer. And if the prey of these killers suffers, then that's just too bad. It's sad, but there's no reason why nature should care whether there is suffering in the world. It doesn't. Nature doesn't care about anything.
And just something I touched upon earlier and forgot to come back to, other planets, the process of being, are they in the process of being formed, or in other words, is there any kind of extraterrestrial activity that plays any part in evolution?
Well, we don't know whether there's any life on any other planets. We now know that there are lots and lots of other planets, that stars throughout the universe have planets. And if you just simply count the sheer number of them, the chances are there must be some that are Earth-like, and so might have life something like ours on it. Nobody knows whether there is any life on any of those other planets. Nobody knows whether the origin of life, the event that got life started on this planet, was a very, very rare event, in which case life will be scattered in little isolated islands around the universe, or whether the origin of life is quite an easy thing to happen, in which case we can expect that the universe will be teeming with life.
And in the appendix to your book, The Greatest Show on Earth, The Evidence Revolution, you've an appendix called The History Deniers. Can you just tell us what you mean by that, the history deniers?
Gallup polls and other opinion polls show that some very large percentage, at least of the American public, have an extraordinarily warped idea of the world in which they live. They think it's only a few thousand years old, and they think that life came into existence suddenly, that there was no evolution, that species aren't related. So they are the history deniers. The history deniers are those people who, because of loyalty to a holy book such as the Bible or the Quran, believe these, what are obvious scientific falsehoods. They are deniers of scientific facts, so I call them the history deniers. And what's disturbing is that there really are rather a lot of them.
Are they going to win in the end, the creationists and the naysayers?
No, I doubt it. I think the more education we have, the more people are going to see the value of science. The evidence is plain. It's not a matter of opinion. It's not a matter of your opinion against mine. It's a matter of looking at the evidence and seeing that it points only one way. And if we can only get more and more people educated, then I have no doubt that the history deniers will become less and less frequent in populations.
There's a charming SMS here. Somebody says, at the age of 14, I know evolution is real. Why can't so-called clever adults? And then somebody else says, is adaptability not the ultimate survival mechanism which may involve strength or intelligence?
Well, adaptability might be an important thing. It probably was in humans, but it probably isn't in some other creatures, where specializing in one particular way of making a living may be the important thing. There are so many different ways of making a living in the sea and on land and underground and up trees and in the air, and they all require different kinds of skills, and adaptability may be important in some areas of life, but not in others.
And then we've only got barely over a minute, but you also talk in your book about unintelligent design. Blunders in nature come not from poor design, but from history. And you say when we look at animals from the outside, we're overwhelmed by the elegant illusion of design, but when we look inside, it's often a mess.
That's right, it is a mess. When you look at something that's been designed by a human engineer, it's always pretty good, and you can see this kind of neat. When you look at a living body, it isn't. And there are all sorts of messes and mix-ups and cock-ups and mistakes, which could only come about through historical accident, which would never have come about if there was indeed a designer. The example I give is a particular nerve in a giraffe's neck, which starts in the head, goes way down into the chest, loops around a big artery in the chest, and shoots straight back towards the head again. That is not good design. No engineer would accept that. He'd throw it out.
Richard Dawkins, it's been such a pleasure talking to you. I haven't had time to go through all the messages or take all the calls that came in, but read the book for yourself. Richard Dawkins, The Greatest Show on Earth, The Evidence for Evolution. Not only is it incredibly accessible to non-scientists like myself, but it's full of great dramatic photographs, diagrams, maps, fossils, everything you could possibly want.